All right, guys, so area between two curves. So when we did this, when we learned about what integrals are, we originally learned that the integral represents the area under the curve, right? What happens when the area goes, or the curve goes below the x-axis?
Negative.
Becomes negative. Okay, so what if we want to find the total area between two curves? We are going to take the upper curve and subtract the lower curve.
Wait.
Because it's below. So think about that for a minute. It's going to take the upper, so think about f of x. If I just do the integral of f of x, it's going to give me this region above the x-axis, right? If I did the integral of g of x, that would give me a negative value, right? So we subtract it and it makes it positive.
And that's total.
And that's going to be total area.
So it's the area of the top curve minus the area of the
Exactly. So it's the integral.
I have a question about this.
What's your question?
Would it be the same as the area is equal to the integral of f of x and then minus the integral of g of x?
Sure. So from that point on, you could use your property of integrals where you can like distribute the integral to both f of x and g of x. That's fine. Good?
Awesome.
All right. So let's take a look. We want to find the area of the region between. So which one is y equals negative x squared plus 6? Obviously that is
Straight line.
the parabola.
What I'm at.
And we have y equals x is here. Now it says from negative 3 happens to be where they intersect, up to 2.
Wow, were they intersecting yet?
So we're looking at this region. Yeah, sometimes they don't tell us the bounds, so you have to see where they intersect. And you can find that using your calculator. This one you could do by hand. So the area is going to be the integral from negative 3 to 2. Which one is the upper and which one's the lower curve?
The upper is 2.
What? This is the upper.
Yeah, negative 3.
This is the lower. Does everyone see that? We don't need the y equals part. We just need the part with the x in it. Okay? So it's going to be from negative 3 to 2. And our integrand is going to be negative x squared plus 6 minus x.
Oh.
Okay? This is upper. This is lower. What's your question, Carmel? So you take,
Never mind. Wait, what? Never mind.
question. Are we,
This is a
okay.
really long lesson.
Right. So this chapter, it's all about the setup of the problem. If you get it to this point, you can pick up your calculator and do math 9 and plug in the integrand, the lower bound, the upper bound. I mean, chapter 5 and chapter 6, we did a lot of practice with integrals, right? Add power. So if we had to do this by hand, it would be negative x to the third over 3 plus 6x minus x squared over 2. Plug in negative 3, subtract it, right? But at this point, I just need to see the setup, and then you're going to do the math 9. We'll do negative 3 to 2. Mm-hmm.
Is negative x squared plus 6 the upper
Yes.
one because it goes higher?
Mm-hmm.
But that doesn't, because the line goes higher than 6.
Right, but the region that is shaded is bound below by y equals x. The region is bounded above by the parabola.
Ah.
You're just thinking about the shaded region. You're not thinking about where they go after that point. Just where the shaded region would be. We're good with this? Just plugging that in? 20.833, so we'll round to the thousandth place.
How would we solve this if we didn't have a calculator?
I just
She just told us.
go back and watch the screencast. I already said it. That's good. That's a good.
That's how we do them with the bound rule. We plug in the upper bound minus the lower
Everybody got that?
bound.
20.8.
Good. Okay, next one. I didn't give you the graph, but we should be able to graph this pretty easily. Hopefully. Y equals 2 minus x squared.
There's a downward.
Maybe if I rearrange it and make it.
Downward curve plus two.
Parabola.
Good.
Up
So
two.
if I rearrange this and make this negative x squared plus 2, like this, and negative x, what's that?
You're being serious. I always get nervous now since that one time.
So I'm looking at this region. Okay, if you weren't sure where the limits of integration, then maybe you were just going to do a quick sketch and we didn't have the graph provided. If I don't give you the bounds, how could you figure out where they intersect? Well, we have this y equals 2x minus, or 2 minus x squared, and this is y equals negative x. If we set them equal to each other, we can solve for the limits. Think about like, okay, if you have the equation of two lines, how do you figure out where they intersect? You can use elimination or substitution. It's something that you learned way back in Algebra 1. But you can also find the intersection of nonlinear equations. So like, where do these intersect? So I'm going to use substitution. I can't use elimination because of the x squared. So this is solved for y, this one's solved for y, so I'm going to set the 2 parts equal. Let's go ahead and solve that. I'll just move everything over to the right side. It factors into minus 2 and plus 1. They're right here. Okay. So x equals 2 and negative 1. These are your limits of integration. Now, if I really wanted to find the y-coordinate, of course, I graphed this pretty accurately, so you could probably just tell. But this is negative 1, 1, and this point is 2, negative 2. I really don't care about the y-coordinate. I just care about the x-coordinate. What's that? The bounds. The lower bound and the upper bound. Limits of integration and the bounds are the same thing, it's just a different word to describe. Okay, so tell me, I have from negative 1 to 2. Remember, I want the smaller x-coordinate to the bigger x-coordinate. I'm working left to right. Just look at the shaded region. What is the upper curve? What is it bounded above by? The line or the parabola? The parabola, the 2 minus x squared. And it's bounded below by negative x, so it's going to be minus negative
Well,
x.
the points that we integrate are the points that in which they intersect.
Where they intersect are the bounds. So on the first one, I gave them to you. The second one here, we had to find ourselves. That's all. Okay, just one extra step. Plug that into your calculator. So go ahead and do that. So math 9. Negative 1 to 2. We have 2 minus x squared plus x. 4.5. Good? Question?
You plug in the x values inside that?
Yeah. Again, this is one that you could have done by hand. You'd have 2x minus x to the third over 3 plus x squared over 2, and then you plug in 2, plug in negative 1, subtract 1.
Oh, you did the derivative?
Okay.
Anti-derivative?
Yeah. Listen, if you find that you plug it, a quick way to tell if you plug in it wrong is if you get a negative answer. Because we're talking about the total area of the region, it has to be positive. So if you end up with a negative, then you put it in backwards. That's just a little note.
Wait, so sorry, can you just go over what you did?
calculator to integrate.
No, it's not, it's not easy to go. It's not easy. No, you will not go to it.
Oh.
That's not it.
That nifty Math 9 tool. Okay. Good? I mean, I could do it by hand, it's just it would take a lot, it would take some time. Okay, this one I have to use my calculator for. So, find the area of this region bounded by y equals 2 cosine x and y equals x squared minus 1 using a graphing calculator.
Alright, remember you did.
Okay. So, first of all, which one is the upper curve, which one's the lower? Which one is 2 cosine x and which one is x squared minus 1?
X squared minus 1 is the.
Okay, the 2 cosine x is on the top.
Yeah. Oh, I found the dominant one.
Bye bye.
Okay, next thing we need to find out, what are the bounds? What are the limits of integration?
So we set them equal to each other. We have
Good.
So 2 cos x equals x squared minus 1.
So if I have this,
Is that what it's called on integration, it's like a bound?
yeah. So 2 cosine x is equal to x squared minus 1. Now, this is not solvable using algebra. So what we're going to do is we're going to go on our graphing calculator. We're going to go to y equals. Now there's two ways we could do this. We could put one of them in for y1 and the other in for y2 and find their intersection points. Or we can find the zeros. I'll probably just, I'm going to put in, 2 cosine x for 1. It's the same thing. I mean, there's like, make sure your calculator's in what mode? Radians. I'm going to do zoom. Oh, you could do the window that they provide there. Or I'll just do Z-trig. Okay, so here comes my 2 cosine x. And then here comes the x squared minus 1. So I'm looking at these two intersection points. How do you get each one? How do we find one intersection? We're going to press second and then what? Calc or the trace button. I don't want to find the 0. I want to find number 5, the intersection. Now it's going to ask you, it's going to say first curve. Yes, I want y1 to be my first curve. Second curve, yes, y2. Now when you press it the third time, it says guess. So use let's say we want to find this one first. So just use your left arrow until it's just closer to that point. It's okay.
What are you doing again?
Just, okay, listen, if you go through that process of finding the intersection and you have more than one intersection, if you want to figure out this one versus this one, you just move your arrow over closer to this side. If you're then going to look for the other intersection, you just use your right arrow and move it over closer. That's all. But this is symmetric, so the nice thing about this, I got what, negative 1.265. Oops. Negative 1, so what's the other one going to be? That's all. So I have negative and positive. Go ahead and write the integrand. So it's negative 1.265
Yeah.
and positive 1.265. So my area is going to be the integral.
We don't care about y.
Nope. Okay, because we're integrating with respect to x, we only use the x coordinate. I don't even bother to write down the y coordinate. Okay, we don't need to. And we established which one was the upper curve, the 2 cosine x. And the lower curve is x squared minus 1, so it becomes minus x squared plus 1 dx. Again, we have it set up. So just go to your home screen. Math 9. You should be getting really used to plugging into your calculator. Yes.
Do you apply the negative to the whole whole x squared minus one, right?
Yeah, I mean, I could have put it in parentheses,
Yeah.
I just distributed the negative sign, that's all.
Sure.
Preston?
My calculator, I had used the slope law and I answered it correctly, but when I put my graph,
It's still there.
yeah, I cleared the drawing. So what's
You were drawing.
Yeah, sometimes, here, the important thing to note, like, when you're using this program, is that you go back and you actually press the button. Otherwise, your calculator, so we still like that? That is weird.
When you put it into A3, you put the bound first, and then X, or X, and then bound.
You put comma X, comma lower bound, comma upper bound. You guys have this? What did you get?
4.99 for. I
4.995. No, go to the thousand, always the
Yeah, I didn't get.
thousand place. That's not what you got?
I got 2.862.
Well, yeah, I did negative 1.265 on bottom and on top. Oh wait, never mind. Oh, I did. I
Okay.
had 2 cos x minus x squared plus 1.
All right, next one. So changing boundaries, right, boundaries with changing functions. Basically, it means sometimes the upper curve and the lower curve might change at a certain point within the shaded area. So we have this example of y equals square root of x. And it's going to be bounded below by the x-axis. So for part of it, it's bounded here. And then here, it's bounded by y equals x minus 2. So essentially, okay, take a look. From here to here,
Yeah.
the curve, see, I want just the shaded region.
Okay.
And notice this line doesn't, I'm not shading in, imagine if that line continued. So it's not just this minus the line. Because look at the first part of the graph. Here, the upper curve is going to be square root of x.
But there's nothing
Right, there's nothing there. So really my lower curve here,
in there that we get.
my lower curve is just y equals 0. Whereas here, my lower curve is equal to x minus 2. So I have to actually
Why
write,
is that considered the lower curve if it's not like actually going below the x-axis?
say that again? What-
Why is it considered the lower curve if it's not actually still
Okay, so remember when we first learned about integrals, what did we say? The integral represented the area under the curve, but it's always bounded by the x-axis. So it's a little, how can I explain this? It's complicated because it technically is bounded here by the x-axis, but then once it gets to 2, it's now going to be bounded by this line.
I think, yeah.
You have to choose two separate.
Yeah, we're going to do 2 separate. So here's how it's going to look. The first one is going to go from 0 to 2 of just square root of x dx. You could put minus 0, but you don't need to. The next part is going to go from 2 to 4 of the square root of x minus x minus 2 dx. We're okay with that setup? So it was like this region counts as one integrand, and this is another one. So
It would have been minus 0 on the first part, but it
it would be minus 0 on the first part. Okay, so,
That's the total area.
right. So go ahead, we want to type this in. I'll just do the square root of x one first. Oops. We get 1.886 plus, what do we get for the second part? It's gonna be, don't forget to change the bound, so it's now 2 to 4. And then we have square root of x. Minus x plus 2. Yeah, I distributed the negative for the second one. So 1.448. Always, in this entire chapter, as in all calculus, unless I specify otherwise, 3 decimal places. 3.333. Okay, that's all right. That's all right. If you use the exact answers, or if you stored them, then your answer might be a little bit different. That's fine. Good. Yeah. Yeah. The next part, we are going to integrate with respect to y. This is no more difficult. The only difference is instead of upper minus lower, we're going to do right minus left. And we use, I'll say we use everything with y. So remember on the previous ones, it was like y equals x squared minus 1, or y. So in this, if we're going to integrate with respect to y, we want to have everything in terms of y now. And in fact, instead of using the x coordinate for the bounds, we're now going to use the y coordinates for the bounds. Okay. So let's look at this same example that we had on the previous page. We can do this with respect to y using one integral. So remember on the previous page we had to separate it into 2 parts? So here, if I'm considering this shaded region here, this is going to be my right curve, and this is my left. Think of it if it was turned around, like can you kind of picture how it would be upper versus lower? Here it's the right, here it's bounded on the left. Good with that? Okay, now, I started out with the line y equals -2. So I want to solve for x. So what would I do? I'd add 2, so y plus 2 is equal to x. Correct? Because we want to have everything in terms of y now. Oh, whoops, I didn't mean to write left. That's supposed to be right. Take my y equals square root of x. How do I solve for x? What would I do?
Square both sides.
Right, I would square both sides. So what do I have? Y squared equals x. So y squared is my left-hand curve. I don't want the part with x. I only want everything in terms of y. So we're going to isolate x for both curves and just use the other side of it.
Is that like the second step?
Yeah. Now, we have to use, what are our bounds? So what is the y coordinate? Where does the y start? It starts at 0. Where does it stop? At, no, 2. The y coordinate. So like this is 4, 2. So I just want the y coordinate for the bounds. So my limits of integration are 0 and 2. So what would the area look like?
Alright, so can I do this calculation?
Okay, so it's going to go from,
So that is from 0 to 2, right?
okay, and then, good. Okay, we don't need to, just minus.
Minus, like this.
Good. And then at the end, we don't put dx, we put dy.
The reason why we have small
Variable.
for, or like the reason why we have to isolate x because we don't want it going past the 4.
Exact. Yeah, we.
That triangle.
Yeah, no, we don't want this triangular part. We want just this region here. So we got that? Now, if you're going to plug this into your calculator, it's not impossible. Okay, you can use the variable y, but I usually don't bother. I just use x. As long as you type it in just the way you see it, you can put any letter you want here as long as it matches. As long as it's x, x,
Like,
and
you mean
x.
like the
How do you put in
alphabet?
Y? So
Yeah, you can use alpha letters.
Oh, you can?
Yeah.
Wait, does the y in alpha letters, does that mean like the actual y? If we were to use it in like the equation?
When you do slope fields, yes. So I'm just going to use x though, I don't know, I just find it easier just to use the variable button. Okay, so you should get the same exact answer that we had on the previous page, right? 3.333.
I have a question. So if we check to the previous page, we have the same,
I gave you the same exact, I did that on purpose.
yeah, but how come one is, we do the
Okay, so you're,
y negative plus and then the
because with x, the lower bound change at a certain point, whereas with y, this is always bounded on the right by just that one curve, and it's always bounded on the left by that one curve. Okay, for example, on a test, I may, or not test, on a quiz, I may give you an example where you can just choose. Maybe it's easier for you to set up the integral with x, or maybe somebody else thinks it's easier to set it up with y. You can, it works. It's either way, whichever way you're more comfortable with. Let's look at this one. Okay, which do you think? Do you think it's going to be easier to solve this using upper minus lower or right minus left?
right minus left.
I would agree. Okay, which one is the right-hand curve?
X to the third.
Okay, so y equals x to the third, and then x equals y squared minus 2. Oops. Now, it's kind of nice that this one's already solved for x. Yeah, remember, when you're using right minus left, you want to have x equals. So let me write that down. So when you use right minus left, solve both equations for x equals. Now, the one is already solved for us. This was our left-hand curve, x equals y squared minus 2. But this one is y equals, so I want to...
If x equals to the third as well.
Good. So if I have y equals x to the third, if I take the cube root of both sides, I get y, I'm going to write it as y to the 1/3, just because it's easier. Actually, you could leave it cube root, it's fine. So y to the 1/3, this is our right-hand curve. What about our bounds?
So one of them is -1.
Okay, so one of them we can probably see is -1, -1. But how, this clearly does not intersect at a point that... Good. Okay, so we're going to graph on our calculator. Go to y equals. So I have x to the third. And what's the other curve?
X plus 2.
Wait a minute. Be careful here.
It's the square root of x. You gotta change it to
So what is it? The square root?
The square root of x plus 2.
X plus 2. Isn't it also negative square root of x plus 2? Yes? Sorry, I have to delete that.
How do you do that? Oh, you put it in.
what are we doing?
Oh, yeah. It will be negative.
Oh, yeah, that has to be. Because when we take the square root of y squared, you get plus or minus. Otherwise, you'd only have this part of our curve and we wouldn't have the lower. Does that make sense? Now, I think this one is easy enough to see. You can find the intersection of these, but let's actually look to see where the red and the blue lines intersect. So, what's the question?
How do you get it to show both sides of the parabola?
Say that again?
Like mine's only going negative throughout the
Did you write both of them?
No, it doesn't negative. Oh,
You
have to write
you have to write both. That's why.
both.
So I get 1.215. Oh no, I'm sorry. What are the limits of integration? They're -1 and I want the y coordinate. I was looking at the x coordinate. What is that? 1.793? Remember, everything, if I'm doing right minus left, everything has to be in terms of y. So including the limits of integration, I have to look at the y coordinates. So I'm looking at this number, 1.793. Okay, so what's my area formula? It's going to go from -1 to 1.793. What was the right curve? Y to the 1/3, good. Minus y squared minus 2, so it's going to become minus y squared plus 2.
Isn't that right down?
I distributed the negative sign, so.
At some point, we have to solve it. Oh.
No, okay, this quiz will all be about setup and answer. So, in fact, most of the problems will have like a part A, I'll say, write the setup to find the area of blah, 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 and then B, evaluate that integral. Now, if you set up the integral wrong, but you, you did the second part according to your setup, I won't dock you points a second time. Just like what I... What do we get? A number. That's fabulous. Apparently mine is thinking. There we go, 4.215. Okay. I think that's it for today.
4.215.